Hello friends, in today's question, one end of a horizontal thick copper wire of length 2L and radius 2R is welded to an end of another horizontal thin copper wire of length L and radius R. When the arrangement is stretched by applying forces at two ends, the ratio of the elongation in the thin wire to that of thick wire is. So we have a thick copper wire. So let us draw a thick copper wire, something like this, and it is welded to a thin copper wire. So this is a thin copper wire, and this is our thick copper wire. The length of thick copper wire is given as 2L, so this is our 2L, and the radius is given as 2R, and the length of thin copper wire is given as L, and radius is given as R. And it says that applying forces at two ends, so it means forces are being applied at this end also and at this end also, being stretched from both ends. So in this case we are going to use the Young's modulus of elasticity for thick wire as well as for the thin wire, and then we are going to find out their respective ratios. We can say that elongation delta L of the wire under tension elongation delta L of wire under tension, and it is given by the formula delta L is equal to F L divided by A multiplied by Y, where F is the applied force, F is the applied force, L is the length of wire, A is the area of cross section of the wire, A is the area of cross section of wire, and Y is the Young's modulus of elasticity. Y is the Young's modulus of material. Young's modulus of material. And it says that both are made of copper, so value of Y will be same. Okay. We can say both wires are made of same material, that is copper, therefore Y is same. Y is capital Y, Y is same. And also the wire is being stretched at the both end, so we can say the force which is being applied on the both the wires will be also same. The applied force F is also same for both wire. since same force is stretching the entire system. Stretching the entire system. So let us find out delta L for the thin wire and delta L for thick wire. For thin wire, length, which is suppose is L thin, it is given as capital L. Radius is suppose given as R thin, is given as R. Cross section area is, let us suppose, is taken as A thin. Cross section area, let us suppose, is taken as A thin, which will be equal to pi r square. Therefore, the elongation delta L thin will be equal to, we have value of force will be same in both the cases. This is L thin, we have area of cross section for the thin wire, and Y will be same. So substituting the values, we get delta L for thin wire is equal to F multiplied by L, and here we have pi r square multiplied by Y. So we get the delta thin. Similarly for thick wire, for thick wire, length is given as, let us put taken as L thick, and that is equal to 2L. Radius is R thick, is given as 2R. So therefore the area of cross section, area of cross section, this is A thick, will be equal to pi 2R square. So we can say elongation delta L thick will be equal to, force is same, length is L thick, area of cross section is A thick, and Y is same. Substituting the values, we get delta L thick is equal to F multiplied by 2L divided by F 4R square multiplied by Y. So this we got as L thick, and we have to find out the ratio of thin wire to thick wire. So we can divide these two equations. So we get delta L thin divided by delta L thick will be equal to FL upon pi r square multiplied by Y divided by F 2L divided by pi 4R square multiplied by Y. FL and FL goes away, pi r square, pi, and Y goes away. And we can also say this comes as 2, so this will be equal to 2. Therefore, the ratio of elongation in thin wire thin wire, not thick, thin wire to thick wire, and that can be represented as delta L thin divided by delta L thick is equal to 2. So the options available to us is, we can see that option number C is the correct one. So you can write that option C is correct. Option C is correct. So this completes the question. Thank you.